Okay, so here we have to multiply the 3 on the Na by 0.30 and we get 0.90. Here we multiply the 2 on the Na by 0.60, we get 1.2. Here we just do 1 Na times 0.60, which is 0.60. Here we do 1 Na times 1.0, which is 1.0. And then on the highest concentration of Na, that means we have to go with choice B. 2. The mass spectrum for a sample of pure zinc is shown above. According to the information in the spectrum, how many neutrons are present in the nucleus of an atom of the most abundant isotope of zinc? Well, the most abundant one is going to be the 64. So the mass number here is equal to 64. And mass number is equal to proton number plus the neutron number. The question now is, what is the proton number of zinc? And if you pull up the periodic table, you will know that it is 30. So we're going to say 64 is equal 30 plus n is equal to 34. We have 34 neutrons. Okay, so here we have 3 different samples of CuO are analyzed. And what's happening is that if we have a 20 gram of CuO, then we have this measurement. If we have 30 gram, we have this measurement. And if we have 40 grams, we have this measurement. Okay. So in all of the measurements, we have 20% of the measurement being oxygen, and we have 80% being copper for all of the different rows. 20% with and 80%. And so elements combine in a fixed proportion. Yep. Question 4. We have a titration of a base with an acid, a strong acid. And the initial concentration of the base is going to be here. We should figure out what that is. So what we can do is we can do MAVA is equal to MBVB. So Ma is the molarity of the acid, 0.040. V is the volume of the acid at the equivalence point, which is 50. Mb, which is the molarity of the base, which we are looking for. And Vb is the volume of the base, which is 20. So Mb is equal to, put the 20 down, 50 times 0.040. And the answer comes out to 0.10 molar. So C. 5. A change in temperature from 10 Celsius to 20 Celsius is found to double the rate of a given reaction. Why is that? So the increase in temperature does not affect the activation energy, so it's not A. So it's not going to be B either. But you will simply now have more collisions whose energy is sufficient enough to overcome the activation energy. And so the answer is going to be choice C. Okay, here we're looking for which element this is, right? Probably. And yeah, and if we can know which element this is, we can know the number of the valence electrons, right? So we can tell how many valence electrons we have by looking at the biggest jump. The biggest jump happens between third and fourth. So this element has 3 valence electrons. So the answer is going to be choice C. We can tell in which group is the element residing, basically. 7. The catalyst has to basically appear as a reactant in the first step and as a product in the second step because the catalyst is not consumed. And on the other hand, the intermediate has to be a product in the first step but a reactant in the second step. And so the answer is going to be choice A. Okay, so here we're adding 0.01 molar of NaOH to magnesium nitrate, calcium nitrate, strontium nitrate, and barium nitrate. Based on the information above, which of the following will be the first to precipitate? Well, that would be the one with the least KSP value, which is that one. So it's going to be choice A. Question 9. For the peroxide-Lowry acid-base reaction presented above, which of the following identifies the role of phenol? Well, phenol does lose this hydrogen. That's why it becomes negatively charged. So it's going to be basically acting as a proton donor. And that means it's going to be acting as a Bronsted-Lowry acid. Yep, so C. Question 10, here we have the binding energy. And we can just say now that this is 1s2, 2s2, 2p6, 3s2, 3p3. So this element is going to be basically phosphorus, as it has 15 electrons. And 15 electrons means it does have 5 valence electrons, right, in the last shell. Here we have 5 valence electrons. Okay. So, let's see. Just because you have 5 distinct peaks doesn't mean you must have 5 valence electrons. Because maybe the last 2 peaks will not going to be 3s2, 3p3. Could be 3s2, 3p1, or 3p5, or 3p6. So A is off. Okay. B is out as well. The peaks has... The last 2 peaks are 1.06 and 1.95. They're distinct and they represent that we have valence electrons in different subshells or sublevels. So we're good there. Question 11. A student investigated samples of 2 pure solid compounds, A and B. Based on the results of the investigation recorded in the table above, which of the following conclusions can be drawn? Okay, so both solids are soluble in the water. Okay, and the only A conducts in the molten state, but B does not. So that means that B is not an ionic compound. So A is out. Okay, and A conducting in the molten state means that A is going to be ionic, or yeah, and also aqueous state. And so it has to be ionic. So the answer is going to be C. Okay, ice at 0 Celsius added to 660 grams of water in a calorimeter. The temperature of the water drops. Okay. So we're going to say MC delta T of the water, which is the hotter object, you must put negative on it, is equal to mass of the ice times the heat of the fusion of the ice, because the ice basically melting. So minus the mass of the water is 660, C of the water is 4.2, delta T means 0 minus 20, is equal to mass of the ice, which is basically unknown, right, times heat of the fusion, which is 330. Okay, let's now do the math. So M is equal to 330 in the bottom minus 660 times 4.2 times negative 20. Okay, let's see how much that is. I got 168 grams, which is choice B. So here it says, which sample of acid has the greatest concentration of hydronium ion? Well, that would be the one with the lowest pH. So the least pH means the most hydronium ion concentration. So the answer is going to be choice A. 14. Which sample of acid has the strongest conjugate base? That would be the weakest acid. And the weakest acid would be the one with the highest pH. which would be sample 3, whose pH is 4.7. So it's going to be C. 15. If sample 2 is diluted with water to a final volume of 20, what's going to happen to the pH? Well, look, if you were to add water, right, that means that you will reduce the hydronium ion concentration. And how would I know that? Because I would do M1 or M initial, V initial is equal to M final, V final. So since you'll be adding water, that will make your V final more, which would make your M final less. And so if the molarity of the hydronium goes down, the pH has to go up. The pH of sample 2 is at 2.3. That means the pH now has to be more than 2.3. So it's going to be A. Okay, 16. Here we have X becoming Y. But we have X is increasing, Y is decreasing. That means the reaction is basically favored to the left side. And so the reaction favored to the left side, that means that the delta G is positive and the K has to be less than 1. So it's not A, it's B. 17, we want the bond angle for the CNHX. So 1, 2, 3, and a lone pair. That's going to be 107 degrees. And the close answer is going to be choice B. Hydrogen oxygen gas are reacting in the presence of platinum catalyst, okay, forming water vapor according to the equation provided. Which of the following changes most likely will increase the rate of the reaction? Okay, so let's see how we can increase the rate of the reaction. If you decrease temperature, you're going to bring the rate of the reaction down because less temperature means less Ke and less collisions. So it's not going to be choice D. Okay, if you decrease surface area, also means less reaction rate. You don't want to do that. Okay. And of course, if you increase the amount of the O2 reactant, you're going to have more collisions with the H2. You can have faster reaction rate. The answer is going to be choice B. Question 19. Which of the following identifies the atom C or N that has the larger atomic radius and provides Y? So look, C and N are basically placed next to each other in the same period, and N has more protons, while C has less protons. And if they're in the same period, well, when the less protons will have more atomic radius. So C must have the higher atomic radius, so it's not going to be A, and it's not going to be B. Yep, it's going to be choice D. 20. Here we have the heating curve. The heat of diffusion, which is the change from solid to liquid, is this point here, which is sitting at 0.94. Heat of vaporization is the longer line from liquid to gas, sitting at 8.2. Okay, so let's see. Heat of diffusion is for the melting, right? Or for the freezing. And so if you were to melt it, you would have to absorb the heat. So what does 0.94 kg per mole mean? That's how much heat is absorbed when you're going to melt 1 mole of methane. And the melting happens at the melting point, which is 90 Kelvin. So it's going to be choice A. Question 21. A sample of a pure oxide of molybdenum, MO, is analyzed and determined to contain 75% of MO by the mass. What's the empirical formula? So look, it's MO plus oxygen. That's going to be 75%. That's going to be 25%. In grams terms, 75 grams, 25 grams. Now it's time to find the mole of the MO and also find the mole of the O. So divide the 75 by the molar mass of the MO, which in the periodic table would be 95.95. O is going to be 25 over 16. So for the first one, I got 0.781. And for the second one, I got 1.56. Now, what do? Divide both by the least, which is the 0.781. 0.781. 781. So 1, you're going to get it 2. So MbO2. Okay. Here we have CO2 and SO2. Which of the following statements about the pressure in the container is true? Let's see the... Okay. So pressure is going to be dependent on the mole if the temperatures are the same. Okay, and here 10 grams of CO2 and 10 grams of SO2 are not the same mole, obviously, right? Because they have different molar masses. So it's not going to be choice A. All right. Now, let's just find the mole of CO2. That's going to be 10 divided by 44. And also find the mole of SO2, which is 10 divided by 64. And so obviously, N of CO2 is going to be more than the N of SO2. Therefore, the pressure of CO2 is more than the pressure of SO2. So, yeah, more moles means more gas particles. 23. Which of the following statements best explains the average speed of the molecules of each substance? If we're looking back here, both gases have the same exact temperature. So if they have the same exact temperature, then they should be having the same exact kinetic energy, but not the same speed, because speed depends on two things. Depends on temperature and also depends on molar mass inversely. So now, since temperature is the same, it's out of the equation. So now speed is going to be inverse with the square root of molar mass. The molar mass of SO2 is going to be 64 gram per mole, while the molar mass of CO2 is going to be 44 gram per mole. So since CO2 has the lower molar mass, it means that CO2 has to have a higher speed. So CO2 must have a higher speed, which is going to be choice D. 24. Which of the following best describes the polarity of each substance? If you were to draw CO2, it would look like this, which means that's going to be a linear molecule. And in linear geometry, where the atoms on the edge are the same exact element, the dipole moments will cancel out, which makes CO2 nonpolar. On the other hand, SO2, if you were to draw it, it would look like this, which means bent. In a bent geometry, dipoles don't cancel out, which makes SO2 a polar molecule. So CO2 is going to be nonpolar, but SO2 is going to be polar. The answer is going to be choice D. Okay. 25. Equal moles of CO2 and SO2 are placed in two separate previously evacuated containers at negative 50 Celsius. So look, if you look back here, right? So the boiling point of CO2 is negative 78.4. And the boiling point of SO2 is going to be negative 10. That means at negative 50 Celsius, right, the CO2 would have already become liquid. But at negative 50 Celsius, the SO2 is still in the gas state. So CO2 has to be a liquid, SO2 has to be a gas. So CO2 a liquid, SO2 a gas, and so the answer is going to be choice A. 26. A mixture containing equimolar amounts of compound X and Y is distilled. Which compound, if any, will initially be collected in the greater amount during distillation? Whichever boils first will be collected more during distillation. And this one here has IMFs of hydrogen bonding. It will boil last, while this one is going to boil first. So compound Y is going to boil first and is going to be collected first. Okay. So here we have a galvanic cell. And a galvanic cell is basically where the higher voltage is the cathode, and lower voltage is the anode. And electrons always leave the anode, because anode is oxidation, cathode is reduction. So electrons have to go from the anode to the cathode, from the aluminum all the way to the lead. Okay, so it's going to be choice A. Okay. Okay, so here we have compound X at various molarities. So here we have from A to C, we are doubling the volume. We also double the moles, so the molarity stays the same. So the molarity of, actually wait, are we doubling the moles? No, we are not, because in A we have 4 moles, but in C we have 7 moles. So it's not the case. But then if we look at D, 1, 2, 3, 4, 5, 6, 7, 8. So from A to D, we double the moles. We also doubled the volume of the container. That means the molarity stays the same. Okay, so it's choice B. So here we have a diagram of 3 different acids. Which one is the strongest acid, or which one is the weakest acid? Whichever has the most hydronium ion has to be the strongest acid. And let's see what's going on here. So we can tell right away that HY is the strongest acid. Reason is because there is no more HY. It has already become hydronium and conjugate base. So HY must be the strongest acid, must also have the most percent dissociation. But to be the strongest acid, you must also have the least pH. So it's not going to be choice C. On the other hand, at Z only gave us only gave us 2 hydroniums and 2 conjugate bases. Okay, while HX gave us 3 hydroniums and 3 conjugate bases. So this means that HZ is going to be the weakest acid. It gave us the least amount of hydronium ion, the least amount of conjugate base. So HZ must be the one with the least percent dissociation. Least. And by being the weakest acid, you must also have the highest pH. You must also have the lowest pK. I mean the lowest Ka. So yeah. Alright, so what's the rate of formation experiment D? Experiment 2, I mean. Let's see. Okay, so let's just look at experiment 1. So the rate of experiment 1 is R, right? It's given to us. K, A squared, that's 1 squared. B to the power of 1, that's just a 2. 4 to the power of 0 is just a 1. So just basically R is equal to 2K. But then experiment 2, what's happening is we have unknown is equal to K again, 2 to the power of 2, B to the power of 1, and C is just, nothing. So question mark is equal to 4K. Right. So basically, if a single R is equal to 2K, how about 4K? That would be twice that as much, so 2R. So C. 2NO2Cl becoming 2NO2 and Cl2. Okay. Reaction takes place in 2 steps, right? And the rate law must have a single reactant of the NO2Cl in the slow step. So it's not going to be A, right? C looks good. B looks good. C looks bad. Yep, the power is 1. That means you must have a single NO2Cl. So it's choice B. Right, so here basically we have a very large K, right? Okay, so that means the reaction almost goes to completion. Almost, but not quite. And the concentration of limiting reactant will become almost zero. So here, which reactant is limiting? It's going to be the Br2. Why? Because you take the mole for the Br2, divide by the coefficient, which is the 1, and you get lower than H2, where you take that 2.0, divide by 1 still, and you get 2.0. So the Br2 almost becomes 0. 33. Okay. The absorbance is 0.24, so let's just match to the graph. And back here, so 0.2 something. Almost. 1 second, did I do it wrong? Let's check again. Yeah, essentially 0.20. So it's choice A. Okay, I didn't mean that. All right. 34. The best wavelength is going to be the one with the most absorbance, which is currently at 700 something. So C. In the second experiment, we're using an add until all the precipitate. Okay, great. So let's just I guess we can, use the mass of the NiOH2 to find the mole of it. And so the mole of NiOH2 would be the mass of it, which is the 0.70 by the molar mass, which is 93. Let's see how much that is. And I got 7.5 times 10 to the power of negative 3. That's the mole of it. How about the molarity? That would be the molarity of the NiOH2. Would be the mole of it divided by the volume, which is just 0.025. I got 0.30, just choice D. Question 36, the concentration of the NiSO4 is more than the actual concentration. That's because there's probably fingerprints. The person did not wear any gloves. Let's see. Yeah, probably there's something also, a contaminant, basically, a contaminant, which the best answer is choice B. Contaminant makes it look like there is more of something than it already is. Okay. And then 2O molecule, the measured nitrogen-nitrogen bond length is 112, but N2O is 119. So the N2O molecule, nitrogen to nitrogen, is 112, which I don't see in the table. And N2O is 119, which again I don't see in the table. So there's probably some sort of resonance. So the bond order is for N to N is going to be 112, which is between 110 and 120. That means there is resonance between the two, right? And so the bond order for a triple bond is a 3, but for a double bond is a 2. It's going to be between 2 and a 3, right? So more than a 2. So it's not going to be A, it's not going to be B. And when it comes to nitrogen and oxygen, right, it's going to be 119, which is between 115 and 147. So it's between 1 and 2, basically, right? So the answer is going to be choice C. 38, right. So here, as we go from left to right, delta S will be negative, right? And delta H is already negative as well. So the rule says if delta H is negative and delta S is negative, then delta G is going to be negative only at low temperatures, which means reaction is going to be favorable only at low temperatures. Okay, so let's see. Yeah, we have to know the value of the temperature, basically. 39. Which of the following compounds is insoluble in CCl4? Now, you must know that CCl4 is going to be nonpolar. They're simply asking which of the following is going to be polar, right? So it's not B. Now, insoluble in the CCl4 but dissolves in the water. That's a poor conductor of electricity, so not ionic. So it's not C. This one is going to be nonpolar. We want a polar that's not charged. So A, it has hydrogen bonding, but it's not charged. So poor conductivity. Question 40. You want a buffer. Look, so the pK is 7.40. You're looking for 7.7 pH. So 7.7, which is the pH, is equal to pKa plus log of an X, right? Which is the conjugate base over the weak acid. So 0.3 is equal log of X. So now the base of a log is a 10. So X is equal to 10 to the power of 0.3, which in the calculator would give you a 1.99. So that means that the conjugate base over the weak acid has to be a 2 to a 1 ratio. And so the conjugate base, which is the OCl negative, right, and the weak acid have to be a 2 to 1 ratio, so it's going to be choice B essentially. Question 21. Let's see. So look, here the reaction is exothermic. That means delta H has to be on the right side. And so if you were to bring the temperature down, then you would just shift toward the product side to make up for the loss of temperature, the loss of delta H. And so by going the right side, the NO2 will decrease and the N2O4 will increase. So NO2 will decrease, N2O4 will increase. Choice C. Question 42. Dashed line. So dashed line has to be a longer bond because the value shifted to the right, and has to be of less bond energy because the value shifts up. Now currently it is Cl2, so we're looking for a longer bond. That means more shells. So it's not going to be A, it's not going to be B. Okay, and the bond length of II is going to be longer, so it's going to be D. Question 43. Most ideally, you want to have the least molar mass, right? We're looking at that. And so that's not going to be A, that's not going to be C, it's going to be argon. And to behave the most ideally, you want to have the most temperature, you want to have the least pressure. So the most temperature and the least pressure, which is choice D. 44. So this one has 4 things on it, sp3. This one has 3 things on it, so sp2. sp3, then sp2. So it's choice B. Question 45. 55. Right. So the O2 became 0.25. So the plus X is the 0.25. And the plus 2X would be 0.50. And SO3 was 0.55 minus 2X, yani minus 0.50 must be 0.05. SO3 has to be 0.05. And SO2 has to be 0.50. So it's choice B. Yep. 46. When a large electrical current flows through a platinum wire, it glows red and emits heat. Okay. So the metal, it emits heat. Okay. Yeah, it's gonna be just choice D. Okay. 47. Okay. So you're having a strong acid, right? HCl with a conjugate base salt. You will get NaCl plus HF. We're looking for the lowest concentration. Okay. So I do see Na, I do see Cl, I do see HF, but I don't see any OH. So it's choice B. Question 48, galvanic cell. This has to be the cathode, the higher number. Lower number is going to be the anode, right? But the actual cell potential is slightly higher than the cell potential predicted. So the predicted cell potential should be 1.56. This one is going to be, let's say, 1.6. Why is that? So it's not about, the surface area or anything like that. Okay. Now what you gotta know is the following. So let's see. If so Q is gonna be, or E cell is gonna be inverse with the Q. So if the Q is more, the E is less. If the Q is less, the E is more. Okay, now we're looking for Q being less. Okay. So I think we should apply the Nernst equation here. Let me pull that up for you. So right now we're looking at this equation, to be specific. Okay, so the question is, will the Q be negative, like ln Q, which will make the whole thing into a positive? So Q is just the product over the reactant. The cathode we don't flip, so it remains like it is. And the zinc we gotta flip. So basically our balanced equation will look like this. Zinc 2 plus with 2 electrons got flipped. So basically we're going to have zinc becoming zinc 2 plus with 2 electrons. Don't flip the cathode. Now multiply everything by 2. So we're going to cancel the electrons. So we're going to have products over the reactant to the power of 2. And so let's see if ln Q is negative. Ln of Q will be negative if Q is less than 1. So let's look at choice A. If Ag is 1, but zinc is less than 1, let's say 0.9, you're going to have 0.9. And ln of 0.9 is a negative. And this is negative. With that, this whole thing becomes a positive, which makes your E cell bigger. So choice A. Okay, 49. We should use the bond energy, which is the bond enthalpy. We must do reactants minus products. So reactant plus 2OH minus products. So ClO, OH with HCl. Let's use the calculator. So I got 73, okay, which is positive. So that means the energy required to break is more than the energy released from the making. So that means if delta H is positive, energy to break is more than energy released. G released is less than energy when breaking. So A. 50. Okay, so here it says that the reaction is going to go to completion, which basically means one of your reactants is going to become zero. That means one of your reactants is going to be limiting. So what do? How do you find limiting reactant? You must find the mole of each reactant and then divide by the coefficient to see. So let's find the mole of CH4, which is to divide the mass by the molar mass, and you would get a 1. Let's also find the mole of O2, which is to divide the mass by the molar mass. You would get a half. Now, of course, you must divide by the coefficient, which is a 1 here. You would still get a 1. And the coefficient here, which is a 2. And you would get a 0.25. So obviously, the lower the number, the one is going to be limiting. So now we know that O2 is going to be limiting. That means it has to become 0. And now we can work with the ICC table. So now we're going to say CH4 plus 2O2 gives you CO2 plus 2 waters. ICC. We are starting with, of course, you must now put the numbers before dividing by the coefficient, meaning you must put 1 for the CH4 and you must put half for the O2. So 1 and half. And O2 will become 0 because limiting reactant. Okay, minus 2x minus x, CO2 was 0, water was 0, plus x plus 2x. And we will get, now we should find out what the x is, right? So now we should say 0.5 minus 2x is equal 0. That means 0.5 is equal to x. X is equal 0.25. So 1 minus 0.25 is 0.75. 1 plus 0.25 is 0.25. 1 plus 2 times 0.5 is 0.5. So essentially now, right, if I divide everything here by 0.25, which is the least, if I divide this by 0.25, I will get a 2. If I divide this by 0.25, I will get a 1. If I divide this by 0.25, I will get 3. Meaning what? That I must have 3 CH4, I must have 1 CO2, and I must have 2 waters in the product side. So 1 CO2, 3 CH4, and 2 waters. So it's going to be choice A. Okay. Let's look at question 51 here. So you want to get the greatest number of coulombs of charge. And the way to do this is to say, if I have 1 gram of metal, which is given to me in the question, if I had 1 mole of metal, that would be the molar mass of the metal. And if I had 1 mole of metal, that would be the number of moles of electrons. And if I had 1 mole of electron, that would be Faraday's constant. And this is going to give you the number of the coulombs. So what we can see here is that the number of the coulombs will be dependent inversely on the molar mass of the metal and directly on the moles of electrons. Okay, so let's start with Ag. Ag has what charge? Plus 1. So 1 over the molar mass of the Ag, which is going to be 107.87. That's for choice A. For choice B, the charge of the Cu is 2. So we're going to put 2 over the Cu's molar mass is 63.55. Next, the charge of Cr is 3. So let's put 3 over the molar mass of Cr, which is 52. That's choice C. Then for choice D, the charge of Al is 3 over the molar mass of Al, which is 26.98. Now you can actually divide these numbers, obviously, and get whichever is the highest wins. So whichever the highest is going to win, which is going to be choice D. 52. Okay, the melting point of two ionic solids is given. The melting point of MgO is going to be higher. So the melting point of MgO is higher, and to have a higher melting point, you have to have one of two things: more charge or less size. Okay, now charge is not mentioned here, so now we should focus on the size part. So let's see how that's going to work here. Okay, so if you were to compare the sizes of Mg, with Na, and also the size of the O ion with the F, we could tell. So look, Mg2 plus has 12 protons and 10 electrons. Na plus has 11 protons and 10 electrons. How would you know which one has the larger atomic radius or the smaller one? There is something called effective nuclear charge. And the size is going to be inverse with this effective nuclear charge. Okay? So how do you find the effective nuclear charge? Put the protons on top, put the electrons in the bottom, put the protons on top, put the electrons in the bottom. This will be more. So the effective nuclear charge of Mg2 plus is more. If the effective nuclear charge of Mg2 plus is more, that results in less radius for Mg2 plus. And so the answer is going to be choice A. So here we have determined the percent by mass of FeSO4 in a solid that contains a soluble unreactive impurity. S2 dissolved 1.50 sample. Okay. Which of following talk about the oxidation reduction reaction? So iron went from +2 to +3, so it did increase, right? But that means oxidation, not reduction. So it's not A. Hydrogen went from +1 to still a +1. There's no change to it. Manganese here was a +8, and here it became +2, so it did decrease, which means reduction. Okay, point based on information. So let's just find the mole of the MnO4 negative, which is 0.010 liters times 0.10, 1.0 times 10 to the power of -3. That's how many moles we have of MnO4. So how many moles would that be of Fe2 plus? It's a 1 to 5 ratio. So that means the mole of the Fe2 plus will be 5 times that. And now we can find the molarity of it by dividing the mole by the volume in liters. So it's going to be choice B. Okay, so here, this reaction is the same as the old reaction, but the coefficients got doubled. Okay? Let's look back at the previous reaction. Yep, everything was of half the coefficient as the newest reaction. So the old reaction had this much E and had this much delta G. And the rule says if you were to affect the coefficients, the E will stay the same. Okay? But delta G is equal to negative NFE. So if N doubles, delta G will also double. So the E will still be 0.74, but delta G now will get doubled. So the answer is going to be choice B. 56. We're essentially reacting FeSO4 with NaOH, FeSO4 with NaOH. We're going to have what we call a double displacement reaction. So the Fe will go with the OH. Fe has a charge of +2. How do I know? Because FeSO4, SO4 has a charge of -2. That means Fe has to have a charge of +2 for them to cancel out. So I'm going to have FeOH2 plus Na2SO4. Now Na2SO4 is going to be aqueous because according to solubility rules, alkali metals will make things aqueous. This has to be the solid. Now what they're asking us is for show only the species that react and the species that are produced, which basically means they're looking for that ion equation. That means you just have to keep the precipitate on the product side and you have to ask yourself what makes it up. It's going to be Fe with 2 OHs. So it's going to be choice C. 7. Okay, we have the Kp. Right. So now we should find the Q, which is going to be products over the reactants. So Br2 is 1.2 and NO is 0.10 squared, NOBr 0.20 squared. And you get 0.3, so K versus Q, put the Q on the left. K is larger, it's at 0.5. Reaction has to be going to the right side. And so NOBr will decrease over time. NO will increase, Br2 will increase. So NOBr will decrease because the K is bigger. 58. Delta H is negative, that means exothermic, we have to go down. And V2O5 is a catalyst that must lower the activation energy. And the solid line is without, dashed line is with. So it's not going to be A. And B is endothermic, even though it must have an exothermic reaction. It must lower the activation energy. Yep, choice C. 59. Okay. So the metal's temperature dropped a lot, while the temperature of the liquid increased a bit. Since the metal's temperature dropped a lot, it has to have the less specific heat capacity. Now they would exchange the same amount of heat, basically, because of the conservation of energy. So it's not A. It's not B. The metal's C has to be less, that's why it dropped in temperature more. So choice D. Okay. So you're going to be using the, just break it up into PB and 2fx, 2x. So 4x cubed is equal to KSP, x is equal to KSP divided by 4 to the cubic root. And I got choice C.